Hello, this is the Science Demystifier, your number one tutor on this channel. Today we are going to be discussing qualitative analysis, or you can simply call it SALT test. So based on the samples or specimens provided, we have identified 3 different chemical species that can be tested for or that we're analyzing in this forthcoming examination. One is lead-2 ion, the second one is trioxocarbonate 4 ion, and the third one is starch. So I want you to pay attention. If you are a student, you're a chemistry teacher trying to prepare your students, for this exam, please, I want you to draw close and pay attention. If there's anything you want me to explain more, please do that in the comment section. Don't forget to subscribe. Don't just watch and you don't subscribe. That's the way you encourage us to do more. So let us go to the board and demystify the process. Let's look at the 3 major constituents we are going to be testing for in this salt mixture. The first one is lead-2 ion. Lead-2 ion, based on the chemical samples provided, the cation that we are going to be testing for is lead-2 ion. Then the anion we are going to be testing for is trioxocarbonate 4 ion. Trioxocarbonate 4 ion. And then thirdly, the compound that we're going to be testing for is starch. Starch. So, as a teacher, as a student, for you to be able to write well in these forthcoming practicals, you have to study around these 3 chemical species. Starting with lead-2 ion, you need to study all the possible reactions that shows or that can be used to test for the presence of lead-2 ion in a solution. Also, all the possible tests that can be used to detect the presence of trioxocarbonate 4 ion CO3 2- in a chemical solution. And then how to test for starch. So without wasting much of your time, let us start with the preliminary tests. The preliminary test is the test to show the solubility of the salt mixture, where they will tell you to dissolve the sample in about 10 cm³ of distilled water and then filter. So this is how the observation table should look like. This is not a new thing. You may have done this with your teacher, or as a chemistry teacher, you may have seen it in your textbook, or you may have read about it. Now we have test column, we have the observation, and then inference. Now you'll be asked to add C to 10 cm³ of distilled water and then filter. Because of the nature of the chemical samples we're analyzing, the 2 substances which we were told that should be mixed in the ratio of 1:1, they are sparingly soluble compounds. So they will dissolve partially. So we have under observation C dissolves partially on addition of water. Okay, so it dissolves partially on addition of what? Water. Then when you filter the solution, you're going to obtain a white residue, and a colorless filtrate. A white residue and a colorless filtrate. So in conclusion, any compound that is sparingly soluble in water is also tagged an insoluble compound, okay? But the level of insolubility varies depending on the degree of dissolution in that solution. So we can say insoluble compound present. So that means that C is an insoluble compound. It's an insoluble salt mixture. So this is the preliminary test. So the next stage now is for us to look at tests for lead-2 ion, all the possible tests that can be carried out to detect the presence of lead-2 ion in the solution. All right. Now, understanding the theory that aligns the test that you want to carry out will make you to know the expected result, not to be beating about the bush. So that is what I am doing here. So I want you to pay attention. Now, to the solution produced in step 1, that is after dissolving the salt mixture in water, the filtrate that is obtained thereafter will be divided into either 3 portions or 2 portions or 4 portions, as the case may be. Now you'll be asked to carry out tests with each of the portions. So to the first portion of C, you'll be asked to add sodium hydroxide. So we're talking about tests for lead-2 ion now. So lead-2 ion is one of the cations that forms a precipitate with sodium hydroxide. So that is why you will be asked to add sodium hydroxide to it. Now, adding sodium hydroxide to it, there are 2 steps. One is in drops and the second one is in excess. If you add in drops, you will obtain a white precipitate. Some will say white gelatinous precipitate. Some will say white gelatinous PPT formed. And when you see a white gelatinous precipitate formed with lead-2 ion, formed with the solution, it is not only lead-2 ion that is present in the solution. There are other cations that behaves the same way with sodium hydroxide. So we are going to see those cations. One of them is zinc 2+. So you are going to suspect all the cations that gives white precipitate with sodium hydroxide. So we have zinc 2+, aluminium 3+, and then the lead we're analyzing, that's lead 2+. So the 3 of them must be inferred. Now, when you now add in excess, sorry, I wrote in drops 2 times. It's supposed to be in excess. When you now add the sodium hydroxide in excess, we want to know if the precipitate that was formed in step 1 will dissolve or not. If it dissolves, there are some of the ions here that will be removed from the inference that we have made before. So there are some of the ions that will be removed. That's if the precipitate dissolves. Then if the precipitate did not dissolve, then there is also some ions that will be removed. Now let us analyze the 2 of them. If you add in excess and the PPT that was formed in step 1 is soluble, it means that zinc and aluminium should be suspected in the solution. That means they are likely present. But if you add and you see an insoluble, which is the one we're expecting, PPT, so let me write it well. We'll say PPT insoluble in SS NaOH. PPT insoluble in SS NaOH. So that means it's lead-2 ion that is present. So we have removed zinc and aluminium because the PPT wasn't soluble in SS sodium hydroxide. Now to the second portion of C, you may be asked to add another chemical, which is the aqueous ammonia solution in drops and in SS. When you do that, you're going to obtain the same result you obtained with sodium hydroxide. It's going to give you the same result, meaning that it will be white gelatinous precipitate formed in drops, and then the PPT will be insoluble in SS ammonia solution. to be insoluble in excess ammonia solution, and the same inference is what we're going to have. Okay, so another test that can be carried out to detect the presence of lead-2 ion in a solution is a test with dilute hydrochloric acid. So also expect this test. You may be asked to add a portion of C. Here I wrote third portion of C plus dilute HCl and then warm gently. Now when you do that, you will obtain a white precipitate. You will obtain a white precipitate which disappears on heating and reappears on cooling. So a white precipitate, a white PPT, which disappears on heating and reappears on cooling, is what formed. So you will obtain a white precipitate that disappears on heating and reappears on cooling. So when that happens, it means that lead-2 ion is likely present. So your inference will be lead-2 plus likely present. Lead-2 ion likely present. Another likely test that can be carried out to detect the presence of lead-2 ion in solution is with potassium iodide. This one is the confirmatory test for lead-2 ion. So you'll be asked to add a portion of C or add potassium iodide to a portion of C. When that happens, you will observe a yellow precipitate, yellow PPT formed. And when you see that, that means lead-2 ion is what? Confirmed. That's a confirmatory test for lead-2 ion. That's a confirmatory test for lead-2 ion. Now, out of these three major tests that I have, discussed with you, be expecting 1 or 2 to come out in this exam. That's my prediction. Now, remember I talked about tests with sodium hydroxide and aqueous ammonia. So that's test number 1, test with sodium hydroxide and aqueous ammonia. And the second one is test with dilute hydrochloric acid. And then the third one is test with potassium iodide. So within these 3 tests, 1 will certainly come out. Or amongst these 3 tests, 1 will certainly come out. Okay, so next is a test for the only anion in solution, which is trioxocarbonate 4 ion. Now, to the residue obtained after the filtration process, you'll be asked to add dilute triazonitrate 5 acid or any other dilute acid, and then pass the resulting gas that will be obtained from that reaction through lime water. When you do that, you will observe an effervescence. There will be an effervescence, and effervescence goes with evolution of a gas. So the gas evolved. When you pass it through lime water, it will turn the lime water milky. So we all know that there is only one gas that behaves like that, and that is CO2, carbon dioxide, from CO3 minus, which is the radical. Okay, the next one is test for starch. So this is a popular test that we all know, and that is the one that involves adding iodine solution to the residue, because after filtration I don't think that starch is a polar compound, so there's no way it will break up into ions. So we only need to add the iodine solution into the residue obtained after the filtration. And when that happens, you are going to experience a blue-black coloration. A blue-black coloration. formed a blue-black coloration. So, and when that happened, you will say starch present. Starch present. So that's the only test we are expecting for starch in the mixture. Alright, so that's the much we can do for now. Please take your time. You can also go through past questions. You can also go through practical questions to see more on these three major chemical species I highlighted from the beginning. Study their chemistry, and it will help you to also add to what I have just explained in this video. So thank you for listening. God bless you. See you next time when I will be discussing other things as it has to do with this present year chemistry practicals. Thank you and God bless you.